Get started? All right, good morning, class. Welcome to Skelton Academy of Math and Science. As you know, we're all stuck here at home, but we're trying to do the best we can to keep us connected with what's happening in the world of education. During this time of being isolated from your friends and even from parts of your family, it's always good to exercise your mind, your brain, your body, your spirit, just to keep yourself motivated. Now, I know you're thinking, why do I have to do this? We don't really know when we're going to get back together, so we want to keep things going. Sometimes that sense of normalcy just helps us stay grounded. So, with that being said, today's lesson is over what we call hydrates. Now you're thinking, what's a hydrate? Hydrate is exactly what you think it means. It means water. So as you know, when you're really, really thirsty, you have to get hydrated. When you're not really thirsty, then there's another word that we can use, even though we never would, that's called anhydrous. Anytime you see the prefix "an" in front of a word, like hydrate, then that means the opposite. So if hydrate means with water, and anhydrous means something without water. Now, how does this apply to chemistry? Well, I'm glad you asked. There are compounds that has water molecules bonded to them. Now, these water molecules are not bonded so tight that we can't get rid of them. It's really very easy to do so. All you have to do is heat up the hydrate, and any water molecules that are attached will evaporate away. So most hydrates, when you look at their compounds, are blue in color. As you heat them up and the water evaporates out, the blue color actually changes to white. If we were in class, we would actually do this lab. So I wanted you to be able to see it work. So on Google Classroom, I have posted a Georgia Public Broadcasting video that has a lab that we would have done in class that shows exactly how this works. So I want you to view it and just see how you can figure out a formula of a hydrate. Now you would do this using something that we've already done, and that's called empirical formulas. So also on Google Classroom, I have put that process there so you can see it. But as you go through the lab, they're going to walk you through it. Now, why is this important? Because those last few questions on your study guide, questions number 23, 24, and 25, you have to use this process of empirical formulas. So by watching the lab, they're actually walking you through it step by step. And the good thing about it is you can actually stop it and watch and see how it works. So really, really try your best to get on Google Classroom and see this video link and watch it. Now, I want to kind of show you what a hydrate formula looks like. So I'm going to hold something up to the camera, and Mr. Skelton's helping me, so if there's some camera problems, you can blame him. And this is what a formula for a hydrate looks like. You're going to notice that it's an ionic compound. There's going to be a dot symbol, which you would think that it's like a multiplication sign, but it's not. I'm going to put in parentheses right above it a plus sign because that's really what this dot represents. And then you're going to see a certain number of water molecules that are attached to it. So I'm going to hold this up. Is it in there, babe? Okay. So what you have here is a hydrate formula. You have an ionic compound, that's magnesium sulfate. You should recognize that as ionic. You have a dot symbol, which really means a plus sign. And then you have a certain number of water molecules attached to it. Now that's one whole compound made up of these two individual parts. Just like if you had a regular compound, it's made up of the individual elements. Well, this is one whole hydrate made up of a salt compound plus a certain number of water molecules. Now, when you name a hydrate, you name the salt first, so that's magnesium sulfate, and then to show that it's a hydrate, you're going to use the number prefixes that we've already talked about with covalent to name how many waters there are. So this would be magnesium sulfate pentahydrate. If I had something like barium sulfate dihydrate, then you would have BaSO4 dot and then the number 2 H2O. See, that number prefix tells you how many water molecules are attached to this salt. So this whole compound is called a hydrate. Now, if you take away the water part, that by itself is what we refer to as anhydrous. And this is what you've been working with all along. So with water, called a hydrate. Without water, called anhydrous. Now, also on Google Classroom, I have put the procedure of empirical formulas. So go back and look at that. And so you can see how this works. And then I want you to finish up that unit sheet, and we're going to then come back probably tomorrow, and I'm going to put a few little extra problems on there to see how you've been doing with this process. I hope this video is going to help. I'm going to try to use these a little bit more. Hopefully you guys can get a good laugh of how I look on camera. The way that you see how I'm dressed is how I'm usually dressed every weekend in some type of athletic attire. And remember, don't just stay inside and play video games. If it's pretty outside, get outside, take a walk, take a hike, stay away from people, 6 feet, no more than 10, and wash your hands. Stay safe, and I hope to see you soon.